Chapter 8, Problem 4. The integral of the square root of x squared minus 25 over x dx. I sent a handout earlier in the course telling you how I approach these problems, but they can be done in different ways. I call this a simple secant. And what I mean by that is I build a triangle where the secant turns out to be simple. So I have x over 5. I want that to be the secant of theta. Well, secant of theta is hypotenuse over adjacent. So I put the hypotenuse being x, the adjacent side being 5. Using Pythagorean theorem, I'd quickly see that the radical that comes out is the same as in my integral, the square root of x squared minus 25. So I have the secant of theta is equal to hypotenuse over adjacent equal to x over 5. Now eventually I'm going to have to replace dx with something. So if I multiply both sides by 5, I get the piece of algebra x is equal to 5 secants of theta. Then I take that derivative, and it's like use substitution to get dx is equal to 5 secant theta tan theta d theta. Now when using the secant, you always use the tan, and the tan of theta is equal to the square root of x squared minus 25. From that picture, it's the opposite side over the adjacent side, which is 5. Multiplying both sides by 5, I see that the square root of x squared minus 25, which is algebra, is equal to 5 tans of theta. So now I have all the pieces of algebra that I need to change into trig, and I've got those trig pieces I'm going to replace in that integral. So the integral of the square root of x squared minus 25 over x dx, we take that square root of x squared minus 25, we look to the right, and we see that that's the same as 5 tans of theta. Underneath it is an x, and we set up x to be 5 secants of theta, so we replace that. And again, dx turns into something relatively long. Dx is 5 secant theta tan theta d theta, and we need to proceed from here. Now in these problems, very often, in fact, I'd say always, something crosses out. So the 5 secant of theta underneath that fraction crosses out with the 5 secant of theta, which was part of the dx. And we get a new integral that's simpler, 5 integral of tan squared theta d theta. And we take a look at that and we go looking for a rule, and often you will find it in this kind of problem, but this time you don't. So there is no antiderivative for tan squared, so we run to our trig identity sheet, and we say that, well, tan squared of theta is equal to secant squared of theta minus 1. And now what we're doing is saying, well, do we have a rule for this? Now the tangent squared of theta doesn't have an antiderivative, but the secant squared of theta does. So we have 5 integral of secant theta, secant squared theta minus 1, and the integral of the secant squared is tan theta, so we get 5 tans of theta. The integral of a 1 is theta, so we get minus 5 theta. Replacing our algebra back from on the right-hand side, we have 5 times the tan of theta turns into the square root of x squared minus 25 over 5, and minus 5. You say, well, what do I do with the theta? Well, theta is going to be the inverse sine, inverse cosine, inverse secant of one of the pieces from that triangle. So I chose to use the arc secant since that's the simplest. So the theta turns into the arc secant of x over 5. So we have then for a final answer, crossing out those 5's, we get the square root of x squared minus 25 minus 5 arc secants of x over 5 plus c. And again, you could have something different for that. You could add an arctan there at the back and it would have been an acceptable answer.